Question 337. A particle moves on the x-axis so that at any time t is between 0 and 4, its position is given by this. What is the average velocity of the particle from t is equal to 0 to t is equal to 1? When position is given, the average velocity of the particle is the slope of the secant line that passes through 2 points at t equals 0 and t equals 1, right? So average velocity on this interval on 0, 1 is equal to y2 minus y1 over x2 minus x1, right? The slope of the secant line. So what's x1? X of 1 is equal to 4 minus 21 plus 18 minus 3. Substitute 1 for t, right? So that's going to be equal to here 4 minus 3, that's 1. 1 plus 18, 19. So negative 21 plus 19, that's minus 2. What's x over 0? X over 0 is just negative 3, right? If we substitute 0 for t, that's negative 3. So average velocity is equal to x of 1, negative 2, minus x of 0, negative 3, over 1 minus 0, 1. So that's going to be equal to negative 2 plus 3, 1, right? So 1 over 1 is equal to 1, right? Question 338. How many times does the particle change direction during the first 4 seconds? The particle changes its direction. Direction of the particle changes when the sign of a velocity changes from positive to negative or negative to positive, right? So let's find the equation of the velocity first. So here is the position, and velocity is the derivative of the position, right? So velocity is equal to 12t squared minus 42t plus 18, right? And we're going to set this is equal to 0 and find the time where the velocity is equal to 0. So let's factor this. We can factor 6 first. 2t squared minus 7t plus 3, right? So that is equal to 6 here, 2t, t, we must have a negative 7, so minus 3 here, minus 1 here, right? So negative 1 times t, that's negative 1t, 2t times negative 3, that's negative 6t. So sum of those two terms is negative 7t, right? So this is equal to 0. So velocity is equal to 0 when t is equal to 1/2 or t is equal to 3, right? So we're going to test the intervals. So let's draw the number line here. Okay, this is t times t, and t is always greater than 0, right? So 0 to, let's say here is 4. Velocity is equal to 0 when time t is equal to 1/2 and when it is 3. So we're going to test these 3 intervals, right? Okay, we're going to substitute any number between 0 and 1/2. Let's say we substitute 0.1. So if we substitute 0.1 here in the velocity equation, then this is going to be negative, right? Here, negative. So negative times negative gives us positive. So this interval is positive. Substitute any number between 1/2 and 3. Let's say I'm going to substitute 1. So if I substitute 1 here, then that's going to be 2 minus 1. That's positive. 1 minus 3, negative, right? So here we have a negative. If we substitute 3.5, then that's going to be positive, right? Here, 3.5, 3.5. This is a positive. This is also positive. Positive times positive gives us positive. So far, so good. So, the velocity change its direction when t is equal to 1/2, right? The sign of a velocity changes from positive to negative, right? Also, at time t is equal to 3, because velocity, the sign of a velocity changes from negative to positive at this time. So the answer is how many times. The question is how many times, right? So we can say twice, right? Question 339. What are all time intervals in which the particle speeds up? Remember, the particle speeds up when the velocity and acceleration have the same signs, right? Either positive, positive, or negative, negative. In these cases, the particle speeds up. Also, the particle slows down when the velocity and acceleration have different signs. Let's say velocity is positive and acceleration is negative, or velocity is negative, acceleration is positive. In these cases, the particle slows down, right? Okay, we have a position here, right? Position function here. Let's find the velocity. Okay, velocity was equal to 12t squared minus 42t plus 18. And we found the values of t where the velocity is equal to 0 in question 338, right? So velocity was equal to 0 when t is equal to 1/2 and 3, right? Now let's find the acceleration. Acceleration is the derivative of a velocity, right? So we're gonna differentiate this function right here. That's 24t minus 42, right? And set that is equal to 0. Acceleration is equal to 0 when, let's see, 24, t is equal to 42, right? So t is equal to 42 over 24. So that's going to be 6 times 4, 6 times 7. That's 7 over 4, right? So we're going to test the intervals. So let's draw number line. Well, that's actually timeline, right? Okay. This is time. The interval was from 0 to 4. So here's the 0. Let's say here is 4. So up here, we're going to test the sign of a velocity. Down here, we're going to test the sign of acceleration. Velocity is equal to when t is equal to 1/2. Let's say here is 1/2. And 3. Let's say here is a 3. Okay, 7 over 4 is 1.75, right? So that's going to be half to between 1/2 and 3. Let's say here is 7 over 4. Okay, so we're going to test acceleration, the sign of acceleration, right? Okay, in question 338, we found out velocity was positive, negative, positive, right? What about acceleration in this interval right here? We're going to substitute, let's say 1, I guess. 1. If we substitute 1 here, that's going to be 24 minus 42, which is negative, right? So we have a negative here. In this interval, let's substitute 3. Okay, here, 3. So if we substitute 3 here, that's going to be, what is it? Is it 84? Okay, well, 84 minus 42, that's that's positive, right? So that's going to be positive here, right? Remember, the particle speeds up when velocity and acceleration have the same signs, positive, positive, or negative, negative, right? So velocity is positive from here to here, but acceleration is negative. Velocity is negative here. Acceleration is also negative here, right? So from here to here, this interval right here, they're both negative. Here, this interval right here, oops, excuse me. Oops. Okay, so this interval right here, velocity is negative, but acceleration is positive, right? But this interval right here, they're both positive, right? So from here to all the way to here. But we have to include 4, right? Because when velocity, when t is equal to 4, when t is equal to 4 here, then velocity is going to be positive, and when t is equal to 4, acceleration is also positive, right? So the answer has to be between 1/2 to 7/4, or from 3 to 4 included. So 1/2 to 4/7. I mean, this must be 7/4, right? Yeah, there's a typo here. This is a 7/4. This is also 7/4. I'm sorry about this. Okay. So the answer has to be B. All right. Question 340. At what time t does the particle have a minimum velocity in the interval from 0 to 4? Let's say we are trying to find the absolute minimum of f on the interval from A to B. Then what we have to do is we first have to find the critical point, right? So set f prime is equal to, and let's say we have a critical point x equals c. Then we're going to perform the first derivative test, right? So this is a x number line. Here's a c. Let's see, here's a. Here is b, right? So first, the derivative test. We have to know the sign of f prime, right? If the sign of f prime changes from negative to positive, then we know that f is decreasing on this interval and increasing on this interval, right? So this must be our absolute minimum. This is relative minimum. At the same time, it is also absolute minimum, right? But what if sign of f prime changes from positive to negative? Let's say from positive to negative, then f increases in this interval, decreases in this interval, right? Then our absolute minimum would be at the end point, either at x equal a or x equal b, right? Because we'll have, it increases, let's say from here to here, and it decreases all the way down to here. Then absolute minimum would be f of b, right? So we have to check end point in this case. Here, the question is asking us to find minimum velocity, right? Here, velocity is equal to, that's a derivative of the position, 12t squared minus 42 plus 18, right? So in order to find the minimum of this, right, we have to find the derivative of a velocity and set that is equal to 0 and find time t where velocity is equal to 0, right? So derivative of this, which is equal to acceleration, right? That's a 24t minus 42. and set that is equal to 0, then we know that t is equal to 7 over 4, right? So let's test this. So here, this is now timeline starting from 0 here. Let's say here's a 4. Here we have a 7 over 4, right? So derivative of a velocity, v prime, or let's say this is equal to a, acceleration, that changes from negative to positive, right? Remember from the previous problem, question 339, we found that in this interval, acceleration was negative, right? In this interval, acceleration was positive. Remember that? This means our velocity decreases in this interval, then increases, right? So this is our relative minimum of velocity. At the same time, this is the lowest point in this interval, right? At the same time, this is absolute minimum velocity, right? So at what time t does the particle have a minimum velocity in this interval? We have minimum velocity when t is equal to 7 over 4, right?